Okay, so this is, I don't know how it's going to go, but basically laser cutting strategies, 3D printing strategies, and workflow between Revit and Rhino. That's the whole idea. So let's start with laser cutting. So Nadia and some of you are looking into laser cutting processes. The first, most important thing I would recommend is cleaning up your Revit file so you only have the things that you really want to laser cut. No, now because we're dealing with Sarah's project, which is a complex project and full of, you know, construction elements and so on. I'm just going to do it with this particular view, regardless of the elements that are coming. Everything is going to come from the view. You need to go to a 3D view that has those elements. You don't do it from a plan, from a section, you do it from a 3D view, okay? You're gonna do an export. So you're gonna do export from that view and you're gonna say CAD, DWG. Okay, here you're gonna see pretty much what is it coming. Now, one thing to notice that under 3 points here, there are several things that you can do in order to make sure that what goes to Rhino, it's the thing that you need. Under solids, you have ACIS solid. This is checked because Sarah probably has clicked it several times before. This gives you the NURBS. This is the geometry that it's cleanest from Rhino. And polymeshes, what it does is triangulate. It creates polygon surfaces, which is the best for 3D printing. Okay, so I'm going to start with the one that is checked now because we want to laser cut. Okay, so we're going to say okay, and we can go back and do it again to look at the 3D printing. Even though we can continue from here to the 3D printer, we will say next. You will save it whatever you want. Make sure you name it in a way that you know, and you're going to say okay. Might take a while if it's a very complex model, but again, if it's a laser cutting project, I don't think it has to be complex. You just need the floor plans and probably partitions and facades. So now don't bring, you know, the cleanest it is, the better. You can clean in Rhino as well later on, but the cleanest means don't bring things that you're not going to laser cut. I don't know, a furniture piece, or maybe you don't need columns at all, any other things that you don't need to laser cut. Yeah, it's not worth bringing them, okay? So that will probably duplicate the view and just hide stuff. And again, you can hide things in Rhino as well later on. It's okay. Rhino, if you haven't worked with Rhino, you won't have time from here to the end of the semester to understand the complexities of Rhino. I mean, it's a great tool for complex geometries, for more parametric driven analysis like with Grasshopper and so on. And it's a great tool to do those things that maybe Revit can't do. Again, we don't have time. There's a lot of tutorials that I can share with you guys that allow you to learn Rhino properly. And I would start from zero. I wouldn't go now into that line of questioning. Okay, so I don't know if it's still thinking. Yes, 50%. So that means that this file is quite big. One thing to notice is that the file, and that came also in the properties that we saw before, I can show it afterwards. It's going to come in feet. So when we go to Rhino, we're going to import it here. But first, it would be nice to know the units. When you start Rhino, it's going to give you something like this set of options. This is the unit setting, and if it's a large file or it's a small file. No? So normally you will click what you need. So is it a large object, small object, which is the only thing that could be doubtful, is basically, I think, large building up. So from building to cities, and then small is basically building down, maybe doors and furniture and things like that, and knobs and details. So we definitely, I think we're in the large object feed. It wouldn't happen too much, so I wouldn't worry too much, but the feed option is something that we definitely need to set.
Can you also do the feet in inches one?
Yeah, you can do feet in inches one. Yeah, there's the command. Rhino is writing whatever you need here, and like in AutoCAD is the same, and press enter and read instructions of what happens. Unit sets the tools. You have the feet here, and then you can set this to feet and inches. The way you insert feet and inches is basically inserting the symbols for feet and inches. Okay, say okay. And basically we need to import whatever comes out of here, but as you can see, it's a 59% element. Maybe I should have canceled it and bring only two things to talk about the example. We'll see. Or meanwhile, I can do a simulation of what's going to come when I import it. It's going to be basically something like this. This is a wall. And then you're going to have something much more complex. And again, this you're not meant to know at this point, but what Sarah's been working with is what is called sub-Ds, which allows you to do irregular shapes.
So like I was asking since we're waiting, so if I import something which I made, say extrusion in Revit, and I import it here, I can still use the sub-D command to maneuver this shapes.
Sub-Ds is a type of geometry.
Okay.
So basically, I don't think you maybe can convert it into sub-Ds. Let's see.
And just see if you just make like a small.
Yeah, you can convert it to sub-D.
Extrusion and just bring it here.
Yeah.
And sub-D will give me all these facets that I can.
Yeah, so maybe that's the way we should go. That's a good idea.
Because like I already made the basic, I just need to like refine it now. Maybe refining it here because I don't know how to use Rhino. I did the extrusion command.
Yeah.
Done, Rhino. I just go to like the Google thing. We usually have a 90-day free trial. So it should be done in 90 days. So
I think it's done. So let me see if this works. Import, as I mentioned, you will bring your DWG file. And again, this is a quite heavy file. Here you need to set both model unit and layout units to feet. They need to be the same. And then you would say, okay. And again, in theory, your project shouldn't be as heavy as this one. I wouldn't bring all of those details that we're bringing now that Sarah's project has. So I will clean up that view. You don't have to save as the file and delete stuff. You just need to hide stuff in the view.
When we hide the things in view, it's not.
They wouldn't come. Exactly.
So you're actually importing a view, not the whole thing. But you save the file in AutoCAD.
Yeah, AutoCAD is DWGs are
universal. I think you can open it in any.
It's a great, because one of the oldest software, so that kind of speaks to everything.
So this is AutoCAD. So even if you had made something in AutoCAD, you could still bring it in Rhino using the data.
You can import AutoCAD files, which is something other people do. You can open the 3D file that I exported in AutoCAD. And if you're an expert in AutoCAD 3D, you can also prepare laser cutting files in AutoCAD. Okay.
But that has to be 3D or 3D.
Well, I'm bringing things to Rhino here, and I'm hoping it helps us both laser cut and 3D print. Okay.
Can you do the laser cut with PDF? Because I think like the class, these people, they had to do one, and I asked her, she said you have to set up the elevations, everything in PDF format, and then laser cut.
Well, PDF, if it's vector based, it is the same as an Illustrator file, and it's not so different from a AutoCAD file. So the answer is yes, as long as it's vector based, the laser cutting machine will accept it, I think. The ideal files they're gonna ask you to bring is AutoCAD and Illustrator. I think those are the two most. Now they also accept Rhino, but from Rhino to AutoCAD and to Illustrator is very fast and easy. So.
Laser. That's laser cut.
Yeah, do you mind bringing this? We can just.
That's from a PDF file, right?
I wouldn't do PDF. I would choose the PDF as the last resource. this is a simple, basically polyline of a tree, and that person took that line maybe from AutoCAD and copied it many times. That person knew the size of the board and made a mistake. So it went outside of the board, and probably the machine was cutting air, which is fine, doesn't matter. And what the machine does again is very simple. It just goes along the line that you have drawn. So if it's an AutoCAD line, it goes there. But imagine you have 3 lines by mistake in the same place. It will go 3 times. So
you need to have like single lines.
yeah, so AutoCAD has an option of overkill. I think it's called the command. It kills the double lines and triples and stuff. I think laser cutting. So instead of the tree, what we need is each of the faces that makes our project. Let's say walls and floors, etc. No. Goodness, I should have chosen a different file. So the tricky question is, I have a complex geometry that is very organic, so then laser cutting might not be the answer. So that's where 3D printing comes in and is helpful. No? Yeah.
I mean, my question was like my original drawing of my site. Because I asked like those people never send me an AutoCAD file, they send me PDFs of individual sections. So just to make the original building and then show what the intervention. I mean, the intervention, I have files which I made. I don't have the whole file on as a 3D. I just have the PDFs, which I have in the past converted them to AutoCAD file, which takes like 5 minutes. So maybe just try the printing on that first.
You can laser cut those drawings too. You can
and make my building first, and then the intervention I can keep adding as 3D and laser cut.
Yeah, maybe you have also the Revit file that is, the old one, or
they never sent me any of the files. They only sent me PDFs because they agreed to send me the AutoCAD files, and then they said no. We asked our management, and they said no.
But here is the thing. It's gonna delete some stuff we don't need, just to keep it clear. Again, imagine this is your file, and you need to laser cut this thing. Well, again, as I mentioned, I think it comes with layers. It's very nice, organized. The same layers that Revit works with. So A stands for architecture, and then S for structure, etc. No? You can just select, for example, the floors. No? I believe you can turn off and on things to see which one it is.
So whatever you turn off here will not appear in the 3D, in the printing, right? The things that you're turning off right now, like all the layers.
Now we need to prepare the thing. So I'm just seeing what we have. Again, Sarah is the expert on this, and seeing what we want to. You can always select something and then check on the properties, say a roof, so we know that's the roof, and go back to the layers, the cake portion with the layers there. And again, you can hide things. I don't know if the walls are there, if you need them, what the yellow ones are, I have no idea.
Probably the window.
Yeah, I mean, it's a complex thing, so you definitely want to clean it up and so on before you do anything. And again, this is a project that has been constructed out of these Revit files. It makes sense that it has all this stuff. I'm just going to use like floors as an example. This is that's floors, that's roof. Okay, so you imagine you want to do the floors laser cutting. Good. And one thing you can do is just, okay, this is what I want, but I don't care about those things. You can always use the command hide to hide things that you don't intend to laser cut. So I'm just using the command hide. It's just another way of hiding things. So this I'm hiding to hide, because again, and I'm not saying that you need to hide them. If you want to have them there, that's up to you. Okay, maybe those are exterior things. I'm hiding them. It's just imagine this is it, no? And again, it will be the same with a wall, etc., etc. Maybe we can put a wall there. You know, those are going to be more tricky, the ones with an angle. But let's imagine we then have the need of these guys. It's a very clean element. We have walls, we have some interior partitions and some roofs. So the question is, the way laser cutting works is that we need a line. We don't need a solid, so that's not going to work for us. So what I normally recommend is that you take this out by copying it. So you can say copy, and you take it from here out. And you go one by one and doing the same thing for all of the pieces. Basically, explode. Explode the same as in AutoCAD gives you the different faces that makes that element. Now we don't need everything, so I can just keep the top face because that's pretty much almost the line that I need, no? So I'm deleting this. And remember I copy it, so I have the original there. And then there's a command which is basically, let me come here. We have the option here, expanding that is called duplicate border. So you can type that directly on the command line, duplicate border.
What is it? Duplicate border?
Border, yeah. So you select the object, and what's going to give you is that yellow line is the border of this face,
It's
no?
going to give you that.
Exactly. You press enter, and then you can take out that line. And we can delete that because we don't need it anymore, no?
So it's more like a 2D plan, which you can also have in AutoCAD.
Yeah, you can take that to AutoCAD.
Could you repeat it again, please?
Yes, somebody's asking me to do it again. So
It's we all need to do it 10. We watched this 10 times before we can figure it out because you did it so quickly and so smoothly.
So this is the element that I brought from here. This is the roof in this case. I need to explode that. Again, you have the video, so you can always take a look at this. Explode it into many faces. Why many faces? Well, one on the top, one on the bottom, and obviously each of these little elements are a different face. Now we only need the line around one of the big faces, no? So this is the one we need. The rest I delete. And here what I use is the command dup border, duplicate border. I start typing. If you're not sure what it is, you search for it, and here it is. So you say that, and it tells you, hey, I have duplicated 3 borders. Why 3? Well, there's one in here, there's one outside, and there's another one in here. So that's 3. Now, when I did that command, it comes automatically with the border selected. So I'm just dragging using the gizmo out. Now, if you don't know what the gizmo is down here. It's just a gumball, sorry, gizmo is other softwares, which is very useful if you're not accustomed to how Rhino works. Now I delete the face because I only need the line drawing. No, I don't need anything else. With this line drawing, I could take it to the laser cutting. Now, remember, this is real scale. So this is 1-to-1 in feet. So imagine you laser cut this, you wouldn't have enough of a, of a piece of paper or whatever. You have to scale it down.
So do you do that here, or do you do it when you send it to the file? Like you tell them this is the scale that I want.
No, I think the ideal place, you should do it, yes. The ideal place is wherever you're most comfortable to reduce things. So what I would do is prepare all of the lines, and if you're comfortable with AutoCAD, because that's well, you know very well, I would take all of those lines from the top view, and I'll explain that in a second, to AutoCAD. In AutoCAD, do your scaling. And again, one of the main things for laser cutting is that we need that rectangle, which is the size. No. We need the size of the laser cutting bed. It's called bed, the space, the surface where you're going to put this material on top. Now the bed, if you go to the to the lab that we have right here and see, is they're going to tell you, well, it can't be bigger than X by Y. No, this is a, if you make it bigger, it's just not going to fit in the machine. So they're going to tell you, don't make it bigger than that. You say, okay, so you're going to have that rectangle, and I'll explain that in a second. Okay, so if you have a wall, and I'm going to do it again with the floor. I'm going to copy this. I'm going to say copy. I'm just bringing it out from here to here. I do the exact same thing, explode. I take only the face above, bring it out, delete the rest, and dupe border, enter, and there we go, and have another one. No? So that already 2 times, 3 times, as many times as you need. If it's a vertical wall like this one, you will do the same. You will say copy, you bring it here. Wait, I did it 2 times. You do exactly the same process of exploding the wall. No, you take the face from outside, you don't care about the rest, and then you do exactly the same, duplicate border. So I'm just repeating the same things. The duplicate border gives you the line work, and the surface we don't need. Now, the floors obviously are at different heights, and the walls are vertical, so that's something to consider, no? Everything should be flat. Let's imagine this is called C-plane, this grid, and AutoCAD has similar C-plane. Ideally, all of those lines are in the C-plane. So I'm going to explain how you do that. Once you have all of these curves, all of the walls are going to be vertical. All of the floors are going to be horizontal, but at different levels. So the first thing you want to do is select this and rotate it. Now, if you have the gumball, it's very easy. You select the arc that symbolizes rotation. You click once to that and you press 90 degrees, no? And there you have it. Now also that's going to be a different height.
Yeah, the levels are different.
I would probably bring everything here, all of the walls vertical, and then I will rotate all of the walls at the same time. And then from the top view, I will go to the area where you have the line drawings. And we need one simple command, which is project to C-plane. I'll leave it there. What does this do?
It brings it all on the same level.
On the thing that I called C-plane, which is the grid. It will just smash everything to the C-plane, which means it will be a horizontal. Yeah. So I do that, and it tells you, do you want to delete the original one? I would say yes, but you could say no and have 2 copies. What's if I do no? You have all of those in the C-plane and those above. I'm going to Control C. If I do it again, project to C-plane, and say yes, boom, they get smashed, but you lose the original ones, which is fine. Okay, so
you can always take them back to the plane that you want. You can make another plane.
Yeah, you can project to a surface. You can, yeah. I mean, ideally, these lines that you're going to laser cut should be in what is called the floor of Revit, which is the C-plane. So, okay, so here is. There are many options depending on how you're going to laser cut. Ideally, is either Rhino, Illustrator. You can do a PDF as well, but to do a PDF, probably you do it from AutoCAD. So I think AutoCAD is one of the most useful ones, but you can do it in any of those vector-based programs. Ideally, you go to top view, I double click there, double click here. You're going to select the line drawings, and you're going to say export selected. In the options, you have Illustrator. If you want to use Illustrator, DWG, that's probably the most comfortable one. And you're going to give it a name. You say laser cut lines, you know, or something like that. Okay. You say it's save. I have this one, but you know, doesn't really matter. I think as long as you can have the 2009s, even the default should be fine. So don't worry about this. Okay. So that you can open in AutoCAD. I don't have AutoCAD open here right now, and I don't even know if I have it installed. But you will see those lines, And the big question is scale. Again, you can't laser cut this at 1:1 because it's huge. It's the building size. So you can do what I'm going to do. You can do in AutoCAD, Illustrator, or here in Rhino and many other programs. In AutoCAD and in Rhino is probably easiest to do. In Illustrator, scaling has to be numerical because manually is a bit more tricky. But anyway, you're going to go to the uh, fabrication lab at SEED and you're going to ask, hey, how big is the bed of your laser cutting machine? And they're going to tell you X by Y. I don't know by heart, but and you're going to create a rectangle. Either
would this be like the sheet size in AutoCAD, like your paper space size?
no, this is paper space in AutoCAD is
Asking because when we obviously print anything from AutoCAD, we make a paper space and then we scale it onto that. So we know like if we're using a 30-40 sheet, then we know we're going to use each size and then we place it according to what scale.
But that's related to printing in a plotter or printing machine, whatever.
Or a
This is
PDF.
this we need to scale down the lines
Oh,
because those are the lines
it
we
has
give to
to
the
be
machine.
cannot like
It has to be like 1-to-1.
model should be the same
the
scale
mouse.
that we want to print.
The lines, I mean, you can scale the whole drawing. You can scale
Yeah.
the drawing.
It's
Sorry,
gonna
the
print 1-to-1
model.
no matter what.
You need to make sure these lines at the end of the day are the exact size that you want them to be cut. That's how it works.
Okay.
So
if it's going to be 1 by 32, then we scale it down by 32.
So let's just imagine the bed of the laser cutting is like, I don't know,
20, 20, 15.
20, 15 or something. So you do a rectangle, and again, this will be exactly the same in AutoCAD. So you will do a rectangle, and obviously it's going to be very small here. No? So you're going to say
15.
20 feet, and you're going to say you say 15, just to put an
That
example.
would be like a foot size.
Okay, so that's notice how well that I don't know if that makes sense. Oh, I put feet. It's not feet. It's rectangle. It's inches. So 20 inches by 15 inches. Now again, this you need to just make sure is that big, and it makes sense because this is the whole building. I mean, we could have scaled down the model and then extracted the lines, but I think this works okay. You have this rectangle. This is precisely where all of the drawings need to go. So if I try to fit in any of those, obviously it's going to be huge because it's the size of a building, no? Makes sense.
So scaling cannot be done in one.
It could be done, and that's what I'm going to do now. You select whatever you want to fit into the sheet, and then you're going to say scale, and this is the exact same thing you will do in AutoCAD. You say scale, enter, and you're going to say, well, what is the proportion? No? So you can say 0.01, and it will do the scale, no? 0.01, and it will do that. No? Now, how big it is, that's an issue of what is the number.
But you got to make sure all your drawings are first laid out and then you scale them together. So none of them are left out.
And also
We have one facade.
number the facades because at the end we don't know which part goes where.
That's the next conversation. Yeah. Yeah. Good point. So the question Raveen brings is, how do we know, when you have 1,000 pieces, which one goes where? Yeah. So that's something I'm going to go back. How can we deal with this situation? Well, as you explode each of the pieces, there's a way in Rhino, for example, to bring in numbers and things like that. So you can annotate under drafting, and you can bring these little guys. Where are they? Annotate dots, for example, and you can just add a display like let's say number 1 or something like that, and you put it on top of the roof. No, does that make sense?
Mm-hmm.
And then you can put that same one here, but you can add, instead of an annotate, you can do a text, which is the command text, then you can add the same number 1. You don't want it solid, you don't want sort of, you want a curve, so that makes sense. And then that will go to our number 1 roof, which is this guy here. So you can put it somewhere here. Now, if it's too small, you can double it. You probably can do that here, just set the parameter for the height. Here, height, you can say, I don't know, 0.5, and put it there. Doesn't have to be very big. And, you know, doesn't have to be very small, so you won't see it, no? Imagine this is going to be scaled down, so maybe it has to be a little bit bigger, let's say 2 times bigger, or you have it in a place where it's not going to be looking bad. And you have to treat this whole thing as the thing to laser cut, because the number has to be there as well, no? Now, do you want to laser cut through it? No, you want to score this element. So you will just draw the number there, and we'll see how that works as well. You will do that for each of them. So when you're done with the pieces, you will see laser cut with the scoring the number 1. You know, that's the piece number 1. You go back to the model and you see, number 1 is this guy. I mean, there are ways to do it parametrically, so all of the pieces get a number, and then automatically all of those get a number, but that's, you need a bit more advanced knowledge of Grasshopper and so on. So I think doing this manually is good. If your project has 23 pieces, it's not a difficult thing. If it has 155, then you're in trouble. But that's just the way it is. I mean,
just need an extra day to build the model.
Yeah, I mean, this.
Not even now we know that our finals on the 1st. We only have 24 days left. Seriously? Yes, they just sent us. And it's on Zoom.
We're,
No,
we're potentially changing that. So yeah. Anyway, so we scale this 0.
Yes. 24.
So what did you scale it to?
I'm scaling this.
Does it not matter as long as you do everything the same, or do you need to know what scale?
I mean, ideally, you know the scale you're making the drawing, your model at. So, no. How do we make sure this is properly scaled? Well, you need to bring your calculator, unfortunately, and because because the US is messed up with scales, and you need to divide by the proper number. So it's a 1 foot equals whatever.
You know, the best thing would be first, I would give this suggestion. Don't print on AutoCAD, but take the whole file to AutoCAD and make it on paper space and see what scale will fit all those drawings there, and then scale it down. Because like you can scale it down to 1/4 and it'll be just like that.
Yeah, it's a good suggestion. So basically, printed in
PDF.
You create a paper space in AutoCAD. So you bring these lines to AutoCAD. You create a paper space that is the same size as the sheet that you're gonna laser cut. Fit it there.
All of them. Make sure that this doesn't happen, right?
Well, remember that you can also just laser cut 2 pieces. So you really want to use the scale you want to use. And if you need more material, you can do several sheets. You don't have to fit it all to one. You know, it cuts one, then another one, then another one. So maybe you need 3 sheets or 4, or you're good with 1. Depends on the project and depends on the scale as well. Now, it's a good idea. Not just suggesting is to print it as if it was a paper space in AutoCAD, making sure things fit nicely, and then come to Rhino or in AutoCAD and scale down the drawings to that scale. How will we make the divisions? And you just need to know what is the scale. 1 foot equals this, and then you do a division, and you know what to insert here when dividing. So I'm not.
1/32 would mean that you divide the whole thing by 32. So that's the scale.
So that would be the number. You would say scale, and then you click once, and then you say 0.0 whatever it is. 53, and some, because the United States is messed up with the scales, maybe it has a 5333, whatever it is, and then once you have that, you bring in the here, and I did it wrong, so I'm just going to do it manually which is incorrect, but you will have your number to do, and then you will fit it in one by one, okay?
And see, that way you also get to see like how you can maneuver your things on the paper space to make the best of your sheet. You don't want like to be cutting four and wasting the rest of it. So,
Why do you have to bring AutoCAD scale drawing?
no, you don't have to.
Okay.
We are just suggesting that because in AutoCAD, the model remains at the real size, right? The actual size. But in paper space, you can reduce the scale. And if you say if you have a 30-20 sheet, you can make a paper space of 30-20 and see what scale will be feasible. I mean, maybe you want to go with 132 or 116, depending on that. It just gives you like a better idea of the scale.
Okay, so yeah, remember every single one. I mean, some of them might not need number because that's the third floor, that with the curve. So
Maybe you just have to go
in many of your cases, you don't need to bring numbers. It's actually quite more straightforward than it is. But in complex projects, you might need numbering. But
For walls,
yeah, for walls, yeah, or because I mean, it's either a small difference that doesn't matter, or it's a big difference. Then it's very straightforward. Again, it's only with very complex models that you need to do the numbering. You will always know where this one is in the facade, the one with the window, la la la. No, but in general, if you're bringing numbers, which is a great guide to know, I wouldn't do it in floors to get straightforward. You need to scale down the numbers and bring them to the sheet as well. Okay. Now, then there's the tricky part of how to organize them. So you lose, material. So you don't lose any material, or as least as you can. Now, this rectangle is the size of the bed. And again, the number I place here, I'm not sure. You have to go to the feed lab and ask them what is that size. But that could be completely different from the size of your material. Your material could be this big, So this sheet here is smaller than the size of the bed of the machine. So this is what you buy in the store. And I don't think they're going to have the exact same size of the machine bed, and probably you don't need it. So you need to have the rectangle of the machine here and the rectangle of your material, which makes sense. And you need to fit things inside, obviously, of your material. So this will be the space to put it in. In terms of one materials, that's you can go also to the seed lab and ask them, but almost everything goes except plastics, which they tend to create fumes and stuff like that. So, but in terms of woods, you're good to go, and so on. I wouldn't put the piece very close to the other one. Give yourself some space because the laser cut tends to burn a little bit around. I wouldn't either put them touching the edge of yours because that's going to be not a safe zone. So bring them always with a little offset to the interior. Okay. And that's your thing.
What about scoring?
Scoring. Okay. So they're basically, and you can ask also in the lab, there's basically 3 layers you need to be aware of. Let's leave it to 2. It used to be 3, but I think 2 is the question. So I believe any color stands for cutting. So I would probably leave black for cutting. And scoring is a different color. I think it's, and I'm going to say red, but it's probably blue. So just don't trust the professor and ask what is the color for scoring to the computer lab, to the fabrication lab. So what you would do is basically go to properties and change the color, maybe display or in layer, and change the color of the scoring. Otherwise, you will cut through that. Okay. So you would say.
And they set that up, like the machine knows like this is the red would be.
Red is scoring, the rest is cutting, etc., etc. Now back in the times, and you can ask them, the interior cuts, they used to be another color, different. But I think the machines are quite smart now, and they go and cut this first. Before you have to say, hey, cut this one first, and then cut the other one. Why? Because if you cut the exterior one,
there's no.
though that piece starts moving, and then if you cut the interior, then you're cutting in the wrong place. So you have to say, hey, first cut here, then cut there. But I think the machines do it now automatically. Okay, so basically you're gonna have two colors, one for anything that is cut, another one for whatever is score. This is the file you send them. And what I recommend is that you always add a text, whether it's in AutoCAD or is in whether it's in Rhino. I would recommend you write down comments to the side of your drawings and say, red is scoring, please do this. You can really talk to them through this. And when you leave the file, you can also try to reach them and see, So, if you have comments, probably smaller, of course, they will read those comments before anything. And if they have any doubts, they're gonna ask you for your phone number so they can contact you before they do anything. Okay. You can say, this is my panel. You can set this is the material I want. You need to bring the material, obviously, and you need to bring in a flash drive your file, your vector
And you
base.
just leave the file for them to do it. Or
They do it.
stand there?
They do it, and the comments are helpful for that. If it's your first time, you can talk to them to make sure things are going correct. Now look at what I have here. I have all this stuff, and then I have obviously this stuff. You can have it here. So I would recommend to save as and make sure only these elements are in the flash drive. Okay. And again, what they do is they laser cut it, and I think they send you a message. Hey, come and pick it up. It's ready to pick up. Okay.
So we just have to provide them with the sheet that we're using and then they do.
The material and the file. You can give them any vector-based file to them. They work with Rhino, they work with AutoCAD, and they work, I think, with Illustrator. I recommend either AutoCAD if you're comfortable with that, or Rhino. Okay. Okay, let me stop that video. So it's one video on laser cutting, and then the next one 3D printing. Stop.